Inequalities in one variable. An inequality has a less than, greater than, less than or equal to, or greater than or equal to symbol in it. And you may also see does not equal, but we're not going to use that in this lesson. So this is the less than. This is greater than. This one over here is less than or equal to. And down here we have is greater than or equal to. How are inequalities different from equations? With an equation, you might have something like x is equal to 3. That means that there is only one number that x can be, and that is 3. Whereas with an inequality, you could have x is less than or equal to 3. So that means that x can be equal to 3, or it can be anything that's less than 3. So 2, 1, 1/2, -5, those are all less than 3. So those are all possible answers for what is x. Also, notice you have the little extra line under the less than symbol. That little extra line is telling you that it could be equal to. That line there means or equal to. So that is why this x could possibly be 3. So in this section, we're going to be dealing with linear inequalities in one variable. So that's going to be something like the ax plus b is less than c. A, b, and c are all going to be numbers, and the only letter here that's going to stay a letter is x. So that's why this has only one variable, because x is the only letter there. X is the only variable. So you've seen that x is less than or equal to 3. This is inequality notation. You're going to need to learn the difference between inequality notation, set notation using inequality notation, and interval notation. So for the set notation, that's where you have the curly braces. Yeah, it's terrible, I know. And then you say, we're using the variable x, but we're only using those x's where x is less than or equal to 3. And then I close off my curly braces. So this is read as the set of all x's such that x is less than or equal to 3. So this bar right here is the phrase such that, or some people will say the word where instead of saying the phrase such that. So the set of all x's when or where x is less than or equal to 3. And then the other notation that you need to know is interval notation. And that is where we use parentheses and brackets to represent whether it's going to be equal to or not equal to. So if x is less than 3, it can go all the way down to negative infinity. And it can go all the way up as far as 3, but it's not allowed to go any further than 3. It can't go to 4, it can't go to 5. And then we ask, is it allowed to equal 3? It has that extra little bar under it. So yes, it is allowed to equal 3. So because it's allowed to equal it, I'm putting the squared bracket on it. Round parentheses, because you can never actually reach infinity, whether it's positive or negative infinity. So the round parentheses means it will not equal. The square bracket means it will equal. And then if we wanted to graph this, there are two ways we can do that. So let me take this away. So I have a number line. I'm going to do it two ways, so I'm putting down two number lines for you. Somewhere on that number line we have the number 0. Somewhere else on that number line we have the number 3. So 1, 2, 3. X has to be less than 3. So, as I said earlier, x could be 2, it could be 1, it could be 1/2, it could be -5. Doesn't matter what number it is, but it can be any of those numbers that are less than 3. Now I have to put the proper symbol at the 3 to tell you, does it equal 3 or does it not equal 3? This does equal 3, and this is where the difference is between these two styles. So because it does equal 3, one of those ways is just give myself that closed square bracket. So just like I did with my interval notation, remember I had the negative infinity up to 3, and I had the closed bracket there. some reason I can't draw an infinity symbol. Okay, so I had the closed bracket there, the squared off one. I can use that same symbol there. Over here, there's a different way of writing it. Instead of using the parentheses to say that it does not equal, and the bracket to say that it does equal, you can use an open dot to say that it does not equal, and a closed dot to say it does equal. So again, I have my 0 somewhere on there. I have my 3 on there. I want to put my 3 down here, and because it says it can equal, it has that little extra bar there, I'm putting a filled in dot there. X is going to be less than that, just like I did over here. So it can be 2, it can be 1, it can be anything that's less than that. So I have my number line going out in that direction. So that is how you would graph an inequality. Next up, the addition property with inequalities. So if you have something like x plus 5 is less than 7, and you want to find out what x is, and you want to get it, that means solve for it, you want to get it all by itself on one side of the inequality symbol. We're going to treat this exactly the same as we would do if that were an equal symbol. So if that were an equal symbol, I would minus the 5. What I do on one side, I do on the other. So the plus 5 and the minus 5 cancel out. I have x is less than 2. There's my answer. The multiplication property, similar, but there's a little extra step in it. If you have something like 5x is greater than or equal to 20, and you want to solve this for x, just like with an equal sign, you would divide the 5 out. And you have x, keep the same sign there, greater than or equal to 20 divided by 5 is 4. So very similar, very, very similar. But there's one difference here. When you are multiplying or dividing by a negative number, you're going to flip that sign. So what I mean, if I have negative 2x is less than or equal to 32. To solve for x here, I need to divide by negative 2. What I do on one side, I do on the other. So my negative 2 times x divided by negative 2 makes the negative 2's cancel out. I have x alone on this side. 32 divided by negative 2. So positive divided by negative gives me a negative. 32 divided by 2, 16. Now I have to take my sign and I have to flip it. So my sign gets turned around. x is greater than or equal to negative 16. It's like having a sock puppet. It's facing away from you, you say something negative, it jerks its head around and it gives you a good stare down. If you're talking to it and you say something negative to it, it turns its head away from you and it starts to ignore you. So when you are dividing by a negative sign or multiplying by a negative sign, that sock puppet is going to turn its head. That inequality sign is going to flip. And then I have a list of summary items. I want you to look at them and I want you to think about them. These are things that you're going to have to know for any quizzes that you're going to be taking or any homework you're going to be doing. And most of it is just, what do these symbols mean? And when do you use the hollow dot, the open dot, versus when do you use the closed-in dot? When do you use the round parentheses versus when do you use the squared off bracket?